finding the asymptotes. The vertical asymptote.
Mr. Kwaku,
Yes, sir. Hello. 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 Can you
good
hear me?
morning.
Good morning.
I can, I can hear you.
Okay. So
Check your volume
asymptote.
small since
Hello. Can you hear me now?
uh, since better.
We are going to look at the asymptotes, and there are three types of asymptote. We have the vertical asymptote, then we have the horizontal asymptote, so vertical asymptote, the horizontal asymptote, and then oblique or slant asymptote. So these are the three asymptotes we shall look at today. Good. Let's pick a first question for illustration. Assuming that we are given y is equal to 1 over x minus 3.
Hello, good doctor.
Yes, sir.
Yes, are you sharing the screen?
Yeah, I'm sharing it.
Wow, I can't see. That's why. Let me check.
We can see. So check
Check your
your
system.
system.
Okay. We'll look at the rules for finding the horizontal asymptote and then the vertical asymptote. Let's look at the rules for vertical asymptote. For vertical asymptote, the first thing is that you must check whether the denominator has a factor in the numerator. Uh, whether the denominator has a factor in the numerator. What I mean is that, for example, if this question was given as x minus 3, s plus 2, all over s minus 3, s plus 4, we can see that the denominator has a factor in the numerator. Because we have s minus 3 here, and we have s minus 3 here. When it happens like that, the s minus 3, which can cancel out the top here, cannot be an asymptote. It would rather be a whole. It would rather be a whole. There's a discontinuity of the graph there. It means as s minus 3, which is when you solve it, you get s is equal to 3. When the graph is moving and it reach that place, it will jump. So we call it a hole. So that's one thing you should check first. When you check and there's two such factor, then the vertical asymptote is just denominator. We equate the denominator to 0 and you solve for the x values. That is be your vertical asymptote. You just equate the denominator to 0 and solve the values of x. That will be your vertical asymptote. But if there's a factor that can cancel out, then as I said earlier on, that factor is a whole, it's not an asymptote. But the remaining portion, so this one s plus 4, that is what we'll equate to 0 to find the vertical asymptote. So let's take note of these key things. So these are the rules for finding vertical asymptote. You first have to check whether the denominator has a component in the numerator, as I've illustrated with this example, and remove that component out before you find the asymptote. Wherever, if there is no such condition, then the vertical asymptote is just equating the denominator to 0. Good. So let's look at the vertical asymptote of the question on the board. So y is equal to 1 over s minus 3. We don't have any expression like s minus 3 at the top. So straight away, we'll say that there is no whole here. If we have another factor like s minus 3 at the top where the s minus 3 can cancel out, then a whole will exist. But that condition has failed. So it simply means that our vertical asymptote can be obtained by equating the denominator to 0. So in this scenario, our vertical asymptote is s is equal to positive 3. So that's the rule for vertical asymptote. First, check whether your denominator has a factor in the numerator. This means that if the expressions are not factorized, then you have to factorize them. For example, if I have x squared plus 2x minus 10, then I have x plus maybe 1. You cannot straight away determine whether s plus 1 is a factor of any of this without factorizing. So when you have an expression such as this type, you have to factorize. It can also be that even the denominator is also a quadratic. For example, x squared plus, let's say, 4x plus 2. So you have to factorize each of them and see whether you are going to get common factors or otherwise common brackets at the top and down. Those ones will cancel out. When they cancel out, the remaining one is what we are going to use to find the asymptote. The other one that was cancelled out will be a whole. So that is that for vertical asymptote for question 1. Let us go to the horizontal asymptote. That one, the rules are very simple. For horizontal asymptote, we have to just check the degree of the numerator and the denominator. They should be compared. The degree of the numerator and the denominator. You must compare them. Good. And these are the results you can obtain. You can have bottom heavy. Bottom heavy means the bottom has more, the degree of the bottom is more than the degree of the top. And then you can also have number 2. They may be equal. The degree at the top and the degree at the down will be equal. The last one you can also have is top heavy. That is, the degree at the top will be more than the degree at the down. In all these scenarios, there's a way of finding the horizontal asymptote. The first one, which is the simplest, when it's bottom heavy, otherwise a proper fraction. If it's a bottom heavy, otherwise a proper fraction, then our HA or horizontal asymptote is simply just going to be what? Y is equal to 0. So in our example here, our horizontal asymptote, because it's bottom heavy, the degree of the bottom is 1. That's the highest power of x, is always called the degree. The degree of the bottom is 1. We don't have any x at the top, so we can say the degree at the top is 0. So this is bottom heavy. And once it's bottom heavy, our horizontal asymptote will be y is equal to what? 0. That is rule number 1. Rule number 2. What about if they are equal?
Hello, sir.
Yes, sir.
Hello, sir.
I can hear you.
Sir, please, can you please go over for me? I just joined, so if you can.
We are recording this today's session very, very short. I want to try and close at 6. I have an assignment to do.
Oh, okay.
So I've recorded it, so I'll put the lesson there so that you can watch it again.
Okay, thank you very much.
So let's look at rule number 2. Rule number 2. Situation number 2, when the degree of the top and the bottom are the same. For example, we can have maybe 2x squared plus 3x minus 1. An example, it's not for this question. Over, let's say, x squared plus 2 plus 2. So in this scenario, the degree of the top, when you say the degree of any polynomial function, we are talking about the highest power of x. That's the degree of the polynomial function. So the degree of the top is 2, because that's the highest power of s at the top. And the degree of the down is also 2. So when it happens like that, we are in case 2. And how do you treat case 2? With case 2, to find the horizontal asymptote in case 2, what you do is that you just divide the leading powers of x, the coefficient to the leading powers. So in this scenario, we just concentrate on the 2x squared and the x squared. We divide their coefficient. So this would be 2 over 1, and our horizontal asymptote will be 2. Our horizontal asymptote will be 2. Take note of that. So that is case number 2 for finding horizontal asymptote. Then a third scenario may arise. That is when the top is rather heavy. The degree of the top is bigger than the degree of the bottom. So we can have an expression such as x squared plus, let's say, 2x minus 1. An example. Then we can have s plus 2. This is just a random example. And this one, we can see that this is top heavy. It is top heavy because the degree at the top is 2. That's the leading power is 2. But the degree at the down is 1. When it happens like that, you ask yourself how many difference. When the difference is just 1, then we are going to have the third scenario, whereby we don't have horizontal asymptote. No horizontal asymptote. When the degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. But when the difference is just 1, then we have what we call slant asymptote. We have a slant asymptote. Or otherwise, some people say oblique asymptote. There's going to be a vertical line, a diagonal line moving this way or that way as your asymptote. That is when the degree of the top is just bigger than the bottom by 1. That is That in that situation, no horizontal asymptote, but we'll have what? A slant or oblique asymptote. If it is more than 2, if the difference is 2 or 3 or etc., there is still no horizontal asymptote, but there will not be a slant asymptote. The slant asymptote, the degree of the top should be exactly more than the down by 1. That is where you get a slant or oblique asymptote. But when it is top heavy, no matter the difference, there is no horizontal asymptote. So let's take key note of this. When the degree at the top or the expression said that it is top heavy, no matter the difference between the degree at the top and the down, there is no horizontal asymptote. However, if the difference between the top and the down in terms of the powers, the highest power, is just 1, then we move into the domain of what we call oblique asymptote. Good. So let's go back to our previous screen. So for this one, we have determined that our vertical asymptote is just equating the denominator to 0 and solving it, and s is equal to 3. And then the vertical asymptote is y is equal to 0. So we have taken note of that. Now, they can ask us to find the domain and the range. The domain is just all values of x. The domain is all values of x except the vertical asymptote. So it can be written as s is such that s is an element of R, but s never equal to what? 3. That is our domain. That is our domain. We can rewrite it in the other way format. That is from negative infinity. We have done this one before. Up to 3, union 3 up to positive infinity. So we can write it in this way using the set beta notation or this form. So this is the domain of this function. Then the range. The range is also all real numbers except the horizontal aspect. So if you want to write the range, you can say the range s is such that s is an element of R, and s is never equal to what? 0. If you want to write it in this form, to be bracket, not a square bracket, it's just bracket. Because the square bracket also have meaning. We've done that in other videos. Negative infinity, comma 0. You close it with a normal bracket, not a square one. The square one has a meaning. Union, open bracket, 0 up to positive infinity. So this is another way you can represent your range. Then they can ask you to sketch. Let's look at how to sketch. Remember, we are not asked to draw. It's a sketch. So it's some few rules that you just have to follow. So first, you must sketch your asymptote first. So this is my x and y axis. And then we got a horizontal asymptote of y is equal to 0, which is still the x-axis. Then we got a vertical asymptote of x is equal to what? 3. So let's assume here is 2, 4, 6. 2, 4, 6. Negative 2, negative 4, negative 6. So my V, vertical asymptote, always we use dotted lines. Will be here. And then my horizontal asymptote is still the y-axis because y is equal to 0 line is the y-axis. So don't need for sketching that one. Then our graph will have two parts because it do not cross the vertical asymptote. The graph can at the right side of the vertical asymptote, our curve can be here or here. Because this is an asymptote, it do not also cross it. So it can either be here or here. Then when we come here, our graph can either be here or here. Good. In order to determine where the graph will be, you only have to plot in few test points. So we'll pick some few test points. So let's go to the left side of our graph. We want to determine whether our graph will be on top of our horizontal asymptote or be at the bottom of our horizontal asymptote, the y is equal to 0 line. We'll pick the original equation, which is y is equal to 1 over s plus 3, no, minus 3. 1, y is equal to s minus 3. Then we pick a test point. On the left side of our vertical asymptote, have a coordinate such as 0 for x. So let's plot that one into our equation. When x is equal to 0, we are going to have 1 over 0 minus 3, and the y value is going to be 1 over negative 3. 1 over negative 3, which is negative 0 point, I think 3333. Good. So 0 negative 0.333 will be below our s-axis somewhere here. So this tells us that our graph will not be at the top here, but rather at the down here for this part. So since it's a sketch, and we know the asymptote does not cross the graph will not cross the asymptote. Just draw something like this over here. Let me even use a different color so that it shoot out clearly. So you draw something like this. Good. Over here. Good. We have finished that part or that portion. Then we'll come to this side to test whether our curve will be on top here or at the bottom here. Will be on top here or at the bottom here. To do that, the same scenario, we'll plug in a few test points. So for s values on the right of our vertical asymptote, we have 4 and above. So we can choose any of them. Let's choose 6 for easy calculation. So you are going to have y is equal, when s is equal to 6, we are going to have 1 over 6 minus 3, and that is going to give us 1 over 3, which is approximately 0.33 positive. So let's go back to our graph. So 6 against 0.33 is somewhere just above the s-axis. It means this, our graph at this portion, will not be at the down here, but to be on top here. So we'll also sketch a curve over there to represent the graph at that portion. So this is the solution for the first one. Whether you want to find the asymptote, whether you want to find the domain and the range, and when you want to sketch the curve.
Book daughter, please can you go
Over again.
From where?
I mean, with the graph especially.
I'll go over the graph once more time. The graph, you have to sketch the asymptote we have obtained. So we have our horizontal asymptote of y is equal to 0, vertical asymptote s is equal to 3. The first thing you need to do is to sketch the asymptote.
Sir, please kindly use right to right.
Okay. The first is to test the asymptote, sketch the asymptote. This is my x-axis, this is my y-axis. The horizontal asymptote y is equal to 0. Y is equal to 0 is still the x-axis, so that one has been drawn. The vertical asymptote s is equal to 3, so you sketch that one. Normally we use dotted lines. This will divide your curve into 4 compartments. These 2 lines, the asymptote will divide your curve into 2 compartments. It means the curve can be here, the graph can be here, there, or there. These 4 compartments. So how do we determine whether the curve will be here, our graph will be here, there, here, or here? These 4 compartments. I say you test, pick test point for S. Then you pick the original equation, you slot them inside. It will give you the idea. So for example, I'm come to use the vertical asymptote. I will pick a test point at the left. At the left, we have points below 3. So we can use any point below 3, because at the left side of our vertical asymptote is from here up to infinity. So you can use any number here as a test point. 2, 0, and the negative numbers. So initially I use 0. This time around, let me use a different number. We have y is equal to 1 over s minus 3. Let me use, let's say, 2. When s is equal to 2, which is, we can find the 2 here, we are going to get y is equal to 1 over 2 minus 3. And my answer is negative 1. So the point is 3, negative 1. Ask yourself where 3, negative 1 lies. If you want to plot 2, negative 1, not 3, negative 1, we pick 2. If you want to plot 2, negative 1, probably somewhere here. This tells us that at the left side of our vertical asymptote, the curve must be in this region, not the top. So we just have to sketch. It's a sketch, it's not a proper curve, whereby we are not drawing. If we are supposed to draw the curve, then we have to plot all points and join them. But this is a sketch. Always we ask to sketch. So we'll draw our graph here. Then we'll go and test the right side. The right side of our equation to find out whether our curve would be here or in this region. Here we have tested it already. We know that to be at the bottom. Whether to be here or here. We slot in a test point. A test point. Any number beyond 3. The first time I use 6. This time let me use just 4. You are free to use any number you like as a test point. When s is equal to 4, we'll have y is equal to 1 minus 4 minus 3. And then we are going to get 1. It means the point is 4, 1. If we are plotting 4, 1, we plot it somewhere here. This implies our curve cannot come here. This is out. So if you want to sketch, it should be here. This is where you must sketch. So let's sketch the curve there. Good. So that will be the sketch for the question 1. Can we go on?
Hello.
Yes, please.
Yeah.
Hello.
Yes, I can hear you.
Okay. So, in the course of testing, assuming you have quadratic function at the numerator and then the denominator, when you are testing, are you going to use the factors obtained or you test with the quadratic given?
Yeah. So assume you have this. This is the original equation. When you are testing, you put it in the original equation. So for example, when s is equal to 0, you put it in the original equation, not the factorized version. But when there's a hole, when there's a hole, when there's a hole, eh, when there's a hole, okay, we'll come to that. You get it. I think I have an example of that. But when you are testing, you slot it inside, unless there's a hole. Uh-huh. Unless there's a hole. So when we come to, I think there's a question like that. So let's go on to question 2.
Thank you.
Question 2, we have a type like this: 1 over s plus 2 plus 7. Mm. So how do you determine the horizontal asymptote or the vertical asymptote of this expression? Let's start with the vertical asymptote. We concentrate on this part. When you have something like this, concentrate on this part. Our vertical asymptote, as we always know, will be equating the denominator to 0. S plus 2 is equal to 0. Give us s is equal to negative 2. S plus 2 is equal to 0. Give us s is equal to negative 2. We just plot in the s plus 2 is equal to 0 direct, because here there is nothing to cancel. The denominator has no factor at the numerator. Good. But if, as I said earlier on from the beginning of the video, if, for example, the top was s plus 2, s minus 3 over s plus 2, then this is a factor, so you must consider that. But there's no such scenario. Then we go to the horizontal asymptote. Horizontal asymptote. The horizontal asymptote of this portion is y is equal to 0. But because there's a 7 there, plus 7 there, we add that. So it goes y is equal to 0 plus 7. So our HA, in effect, becomes y is equal to 7. So let's take note of this type 2. Good.
Hello.
Yes.
Please, this 1 minute. Please, how you got the y equal to 0, please?
We joined so later, late. We didn't join in the beginning. Please, today I'm closing early because I have to wrap up with my school timetable.
Okay.
The rules of finding horizontal asymptote, I'm going over again. Let me see whether they are, I wrote them here or I cleaned them. Okay, let me just. When it comes to asymptote, horizontal asymptote, there are 3 cases. Case 1, case 1, when the expression is bottom heavy, or otherwise a proper fraction. When you have ax raised to the power n plus bx raised to the power n, n blah 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 blah, etc. Then you have maybe the down is also ax raised to the power k, b x raised to the power blah blah k minus 1, etc. You compare the degree at the top, the power, the highest power at the top, that's called the degree, and the degree at the down. So in numerical terms, let me just write an expression. This is bottom heavy because the degree at the top is 2 and the degree at the down is 3. We compare the highest coefficient, that is the degree. The highest coefficient of any polynomial function is the degree of the function. So in this case, this is a proper fraction because the degree at the top is lesser than the degree at the down, what we call the bottom heavy. When it happens like that, your vertical asymptote is just y is equal to 0. Then
Thank you.
we have case 2. Case 2, where the numerator and the denominator has equal degrees. They have equal degrees. When they have equal degrees, an expression such as s cubed plus 3x squared plus 4 all over, let's say 2x cubed minus 3, an example. The degree at the top is 3, and the degree for the down is also 3. So equal degrees. In that scenario, the horizontal asymptote is y is equal to dividing the leading coefficients. The leading coefficient. When I say leading coefficient, look for the highest power of x at the top. There is 1. So the leading coefficient for the top is 1. And the leading coefficient of the down is 2. So our horizontal asymptote will be equal to what? Half. Then case 3. Case 3, where we have top heavy. Top heavy. Top heavy. When it's top heavy, straight away, we don't have a horizontal asymptote. When it's top heavy, no HA. For example, if I have x squared plus 3x plus 6, this is just a random expression. It doesn't represent anything. So randomly, I'm going to just write another one, s 2s plus 1. So this expression is top heavy. So it doesn't have a horizontal asymptote. Then you can move on to perform further test. Whether aside, even though it doesn't have a horizontal asymptote, does it have another asymptote aside the horizontal asymptote? Yes, it will have an oblique asymptote. Oblique asymptote or slant asymptote if the degree of the top is just bigger than the down by 1. So if you look at this one, the degree at the top is 2 and the degree at the down is 1. The difference is just 1. So we are going to have an oblique asymptote. And to obtain the oblique asymptote, use long division. Long division. To obtain the quotient, the quotient becomes your oblique asymptote. So you have to just perform the long division that we've been doing with polynomial function. You divide this by this. Assuming when you divide, the top is x plus 1. That's what you got as the result of your division. Forget about the remainder that you get here. It's not necessary. We are after the quotient. So that will mean your oblique or slant asymptote will be s plus 1. Let's take note of that. Let's take note of that. Okay, so these are the
So,
rules. Right
Hello,
here.
good
yes.
doctor.
Yeah.
Hello, good doctor.
Yes, sir.
So let's assume that the S square is at the down.
Mhm.
The S is at the down.
Yes.
And then let's say at the top, you have, let's say, 1. Let's just put 1 there.
Uh-huh.
So in this case, can we have both horizontal and oblique asymptote?
No, you didn't follow the
No,
discussion.
no, put x at the top, rather x at the top. Now the difference is 1. So can we have oblique and at the same time, what do you call it, horizontal asymptote? Since a
Which case?
proper.
Proper fraction.
I
It's
gave
the
you
proper
three
fraction.
cases.
I think that there's a bottom heavy typo.
Yes.
No,
This is
I'm not.
bottom
My
heavy.
question is, once you were saying that for the oblique there should be difference of 1.
Listen, I said there are three cases. Case one is bottom heavy. Case two, all equal. Case three is top heavy. So this one, which type is it?
Okay, doc, write this. S
This
square,
is one.
S square,
This is bottom heavy.
S square plus 2x minus 1.
S squared plus 2x minus
Minus
1.
all over S plus 2. This is what you use. And
Yeah.
then you were saying that the difference between the S square and the S is 1. So you can get oblique asymptote over there.
Yeah.
And I'm saying that if you should turn it upside down to the extent that the numerator will come down this time.
So when you turn it upside down, it moves to
Mhm.
case one.
Yes,
No
and my
longer case
question is,
three.
the difference is still 1. Can we still have oblique asymptote also there?
In case one, I didn't talk about oblique asymptote.
Okay,
Don't
It
forget.
doesn't work like that.
Huh. In case one, I didn't talk about oblique asymptote. Oblique
okay,
asymptote is in case three, top
okay,
heavy.
There's one. It looks like it's improper fraction.
Improper fraction. That is
Yes.
okay.
where uh, the reason
Oblique,
why the difference supposed to be one is that if I have x cubed plus, let's say, 3x plus 2, and I divide it by s plus 1, our expression that we are going to divide, when you divide this by this, you are going to get quadratic. When you divide this by this, you are going to get x squared. Eh? Let's attempt to perform this division. S cubed plus 3x plus 2, then s plus 1. This goes here, s squared times. So whatever I'm going to get here will not be a line, it will be a quadratic equation. I hope you get it. So the difference should be 1. So that if here was s squared, and here is s squared, then when you divide, we are going to get s, then plus something. So when we have y is equal to s plus something, y is equal to x plus something. This is a line. Eh? The oblique or slant asymptote is a line. So your results that you are going to get will mimic the equation of a straight line, which is y is equal to mx what plus c. I've got it. It should not resemble a quadratic expression, which is s squared plus bs plus c, because we said what a slant asymptote or an oblique asymptote. It's a line, slant. When you say something is a slant line like this, it's a line. So the only way to divide this by this to get an expression of the form y is equal to ms plus c is when the difference is 1. When you divide, you will get x power 1. You see, the power of y is equal to ms plus c is 1. That's the only way you get an equation of a line. If the degree is more than the down, the top degree is more than the down by more than is 2 and above. uh, right.
Banka.
Let me just use the ruler.
Mm.
Okay. If the degree at the top, the difference is so much. As an example is what I've given: s cubed plus, let's say, 3x squared plus 6 over x plus 1. When you perform this division, the results will have your results will be containing x squared, and y is equal to x squared plus anything. It's not a straight line, so that cannot resemble an oblique asymptote. I hope I'm clear. Hello.
Hi.
Yes.
Mhm.
Yeah.
Uh-huh. But if it is x squared plus 3x plus 6 over x plus 1, when you divide, perform the division, you are going to get x, or even that it can even be a number attached to it. So ax plus something. In that instance, this expression is a straight line, and that will represent your oblique or vertical asymptote. So that's the more
So,
reason
sir,
why
if you get,
Mhm.
hello,
Yes,
if you get y is equal to a quadratic, what are you going to do?
that is not a slant asymptote. And as I look into the slide, it's up to what do you call it? It's up to a slant asymptote.
Okay,
You don't have an asymptote which is in the quadratic form. Uh,
okay.
okay. So let's restrict ourselves to the domain of our, what do you call it? The content of our course. It's always a slant asymptote where the power just exceeds the denominator by 1. Okay, it's 3. Slant asymptote. And there is no horizontal asymptote. Good. I hope we have understood all these three cases for the horizontal
Yeah.
and slant asymptote.
Yes,
So
God bless you.
okay. Let's go to the domain and range. Sometimes they will ask us to find the domain. The domain is all values of x except the vertical asymptote. So from negative infinity up to negative 2, we use normal brackets, not the square ones. Then union negative 2 up to positive infinity. Then the range, if you're asked to find the range, everything except the horizontal asymptote. So negative infinity up to 7, union 7 up to positive infinity. Good. Then we can also be asked to sketch the curve. We can also ask to sketch the curve. So first thing to sketch the curve is to draw your axis. After drawing your axis, you draw the asymptotes. So this is my y-axis, my s-axis. So my asymptote were x is equal to negative 2, and then y is equal to 7. So let me see, here is 2, 3. Okay, let me even use a bigger scale. 5, 10, 15. Then negative 2, negative 4, negative 6. Then we have 2, 4, 6, and blah blah over here. So we'll sketch the asymptote. So 7 will be somewhere here for the horizontal asymptote. Then negative 2 for the vertical asymptote. X is equal to negative 2 for the vertical asymptote. After drawing these two lines, we'll have 4 compartments. This area, this area, this area, and that area. We need to know, test where the graph will be. Just test. So plug in some test points, few test points. The original equation is y is equal to, let me use the other space so that other page so that we don't soil our graph. Y is equal to 1 over x plus 2 plus 7. So plot in a few test points. To the left of the vertical asymptote, we have a point such as -4, -3, -5, -6. You choose any one that is convenient for you. So let's use when s is equal to -4. When s is equal to -4, we just plot it inside and test where it will lie. So we have 1 over -4 plus 2, and that will give us negative 1 over negative what 2, 1 over negative, which is negative half.
Plus
Sorry,
7,
let's
plus
plus
7.
7. So negative half plus 7 will give us 6.5 or 6.5. I hope I'm correct.
Yes, it's correct.
Okay, so we go back. So if this is y is equal to 7, it means my -4, so this is the coordinate, -4, positive 6.5. That's the coordinate. This is 7. So it means my positive 6.5 will be below this line. It will be below this line. So straight away, this portion is out. So it means my curve will lie here. It's a sketch. So we just draw our curve here. So we have finished testing this region. It means the top portion is out. Here is out. It's only here that passed the test. Then we go to the right side. The right side, we have two compartments. Either the graph will be here or it will also be here. So we test. Let's test with any value of x from the -2 and above. We can pick any value we wish. So let's pick a number such as 0. Oh, sorry. Okay, so when x is equal to 0, we are going to have y equal 1 over 0 plus 2 plus the 7. So that will be 7, 1 over 2 plus 7, which is 7.5 or 7.5. So the coordinate becomes 0, 7.5. So let's go to our graph and see where that one lies. 0, 7.5 means it is above our, because this line is y is equal to 0. I hope you remember. Y is equal to 7, sorry. So this means this point lies above our horizontal asymptote. So it means here fails, but this one will pass. So our curve will be in this region. We go and sketch it. It's a sketch. Good. So that will be,
So, Doc,
yeah.
I want to know the difference between the sketch and the draw.
Drawing,
Does it mean that when you are sketching, we will not use any ruler or anything?
oh, you
We
have
just
to
use
use
it.
rule. You have to use rule. By the drawing, the sketch is not to precision.
Oh, okay.
When we ask to draw, then we have to use a graph sheet.
Okay.
We will use a graph sheet. You want to draw, then you have to use a graph sheet so that you can get the skills and everything all right.
Okay.
However, sketch, you will do it in the answer booklet.
Okay. Okay.
And it will not be
Okay.
up to precision.
Okay.
That's the
Thank
difference
you.
between a sketch. A sketch is not drawn to precision. It is not precise.
Okay.
Whatever is there is not precise. It's not precise.
Thank
Okay.
you.
Yeah. So let's look at another one. y is equal to 6x minus 8 over 2x plus 4.
Hello, book doctor.
Yes.
Please, the graph.
Yeah.
When we drew the asymptotes, they were two.
Yeah.
So are you sketching the graph for only the vertical asymptote?
No. We have two asymptotes, vertical and horizontal.
Okay. Okay, so the right graph is on the horizontal asymptote,
It's not on. It shouldn't touch it.
and it won't touch it. Like it's just an example. It's other side.
Come up with your question clearly because I'm not understanding your question. Repeat. Rephrase.
Okay.
I mean, I don't understand the question, so I don't know how to.
Don't worry, I've seen it. Thank you.
Oh no. Feel
I've seen.
free. Feel free.
I was wondering where that the second graph will be, where it will start from. So it starts from the vertical asymptote, close to the
Okay.
vertical,
Very good. I've
and
understood.
passes through the.
I've understood your question now.
Okay.
Your the curve should not touch the asymptote. This one it goes to
Mhm.
infinity. 6. It goes into infinity. So you draw it as long as your graph can
Okay.
but you shouldn't touch it. So as it is
Okay.
coming, it's be getting closer to the line, but it shouldn't touch it. And this point to
Okay.
coming to getting closer to the line, but you'll never touch it. It's up to infinity.
Okay.
Up to infinity.
All
It
right.
doesn't have an end point. So this portion too is up to infinity, but it will never touch the asymptote. It will never touch it. And this
Okay.
will be the same thing. Uh, it will never touch the
All right.
asymptote. It's up to infinity.
Okay. Thank you.
Okay. Okay, so we go on. The next one. This one. Good. Let's start with the horizontal asymptote. Which case is this one?
Equal degree.
Equal degree.
Equal.
So this is case 2, equal degree. When it's equal degree, the horizontal asymptote is simply dividing the leading coefficient. So here will be 6 over 2. And that should give us 3. So that's the horizontal asymptote. Then let's go to the vertical asymptote. The vertical asymptote. As I said earlier on, before you do the vertical asymptote, you must always check whether there's a hole. A hole exists when you can factorize the top into two expressions, such as this: s plus 2, s minus 2, then maybe the down s plus 2, then s plus 5. You see s plus 2 and s plus 2 cancel out. So when considering the vertical asymptote, we don't consider the one that can be cancelled out. We only use the remaining portion. The one that cancelled out is called a hole. So here, if you have a situation like this, our hole will be s is equal to minus 2. The vertical asymptote will be s is equal to negative 5. Good. So we can see that even though we can factorize this expression, but we can't factorize in such a way that some of the x will cancel out. It's only the what do you call it? The constant that can be cancelled out. So we can just go straight away and find our vertical asymptote. I hope you understand what I mean. Here, if we factorize the top, the 2, we can factorize 2 out, and we have 3x minus 8 over here. We can factorize 2 out, s plus 4.
Minus 4.
So what is cancelling out are just constants. It's not x. So here there is no whole. If the s
3x minus 4.
3x minus 4, the first one. Oh sorry, 3x minus 4. If it's here and here can cancel out, then we can say that will be a whole. But here, what is canceling out are constant. It's not x value that are cancel out. So there's no whole in this scenario. So here, our VA is 2x minus 4 plus 4 is equal to 0 to give us s is equal to what? Minus 1. Minus 1. So that is that for the asymptote. Then you can be asked to state the domain and the range. The domain is just
No,
all values s
It's minus 2. VA is minus 2.
minus 2 is true.
yeah,
Okay, let me do that
yeah,
correction. I'll do that.
-2.
Minus 2. Thank you very much. I'll do that correction. So it is negative 2. Negative 2. Correct. These are some of the petty mistakes man is bound to make during the exams. May God help us. Okay, so the domain will be all values except the vertical asymptote or any whole. But here there's no whole, it's only the vertical asymptote. So it's from negative infinity up to negative 2 union negative 2 up to positive infinity. That's the domain. Our range will be all values except the horizontal asymptote. Negative infinity up to 3 union 3 up to infinity. So that's the range. Okay. Then let's look at the sketch. You first you always
Good
start.
doctor, please go back small for me. We want to write. Okay, thank you. Please, you can move on.
So we want to find out sketch the curve, the graph. You first have to draw your axis, our y-axis and x-axis, and indicate our asymptote. So y is equal to 3 for the horizontal asymptote, and then negative 2 for vertical asymptote. So let's assume here is 2, 4, 6, 8, negative 2, negative 4, negative 6, 2, 4, 6. So my vertical asymptote is negative 2. My vertical asymptote is negative 2. Then the horizontal one, y is equal to 3. Y is equal to 3. It will divide the curve into 4 compartments. The space into 4 compartments. eh, 4 compartments. Then we have to test where in this 4 compartments can the curve. Our curve cannot be in all the 4 compartments. We have to test. So we'll pick the original function. Then we test, put in test values. So let's do that at the next page. So the original function is y is equal to 6x minus 8 over 2x plus 4. So let's look at one test point. You can pick negative 4 when s is equal to negative 4. You have 6 times negative 4 minus 8. Then 2 times negative 4 plus 4. We'll have negative 24 minus 8 at the top. negative 8 plus 4 for the down. You are going to have negative 32 for the top and negative 4 for the down. And then that will give us negative what? Uh,
Positive 8.
Positive
Positive
8.
8.
Okay.
Positive 8. Positive 8.
Positive 8. Okay. Our coordinate will be negative 4, comma 8. So we look for the region in which negative 4, comma 8 will be. And negative 4, comma 8 will be somewhere here. So this is our test point. So our curve look like this. We shouldn't touch the asymptote. Good. Something like this. Then we'll go to the right side. The right side we can use 0. 0 will make it simple. So when y is equal to 0, sorry, x is equal to 0. When x is equal to 0, we have y is equal to 6 multiplying 0 minus 8 over multiplying 0 plus 4. So the top becomes negative 8 over 4, and this will give us negative 2. So the coordinate is 0, negative 2. Let's look at where that one will lie. 0, negative 2 will be somewhere here. So it means our curve will pass here, pass through here, like that to infinity. If you want to increase your precision of your curve, you can pick more than 2 test points. Increase the precision of your point, your curve. You can use more than 3 test points, more than 1 test point, so that, for example, at least you will get some more dots to draw through. So you can pick maybe negative 1, 0, 1, 4. If you want to draw, increase the precision of your curve, you can increase the test point. You can increase the test point so that you get about 3 or 4 plotting, then you draw your curve through. I hope you understand what I'm implying. Good. So this will be the sketch of this one. Let's look at another one.
Hello, sir.
Yes, sir. I'm listening. I'm listening.
Please, if you are testing,
Pardon?
how you manage to get basic. I'm talking about when you are testing this thing.
Yeah.
The
Yeah.
first one is
The
and
first
then
one
the
is what?
second one when x is equal.
Yeah.
When you are testing, you use when x is equal to negative 4.
Yeah.
And then second one when x,
Yeah.
please. My problem is how you manage to get those
Okay.
figures.
This is the you use the vertical asymptote. Mhm. Initially, I said when after drawing the asymptote, you see that anytime you draw a plus sign, uh, anytime you have a plus sign like this, you have 4 compartments. Is that not it? 1, 2, 3, 4.
Yeah.
Uh-huh. So after drawing your asymptote, we'll have these 4 compartments. The graph cannot be in all the compartments. You must test. And you test by using the points on the x-axis. So this is our vertical asymptote. I'll test to my left and see whether on my left side the graph will be on top here or to be at the down here. So you can pick any values here up to infinity that you wish. Any values here up to infinity. I use -4.
So starting from -2
Yes.
going left.
Yes. I use
Okay.
-4. Somebody can use -6. Somebody can use -8.
Okay.
Somebody can use -10. I even added that to even increase the precision of your curve, you can even use more points. Eh? More points. So I did a -4, and that is where it was. -4, there's the plot. You could have done -6 and even also plot it. Maybe you can go to, let's say, -8 and plot it. So about 3 or 4 points, they will guide you to even draw your curve very well. You understand? They will guide you to draw your curve very well. Uh-huh. So that will be that. It means all the values that you will pick from -4 up to infinity, they will all lie above the horizontal asymptote.
Okay.
Later on, when you are free, this is the equation. Mhm. Our horizontal asymptote was y is equal to 3. Y is equal to 3. Test values. Test values of x less than -2. Any value less than -2, you are going to get a number above 3. You can test that. You're going to get a number above 3. Any value less than -2 here, you get a number less than. Let's 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 just even do a random test and pick a bigger negative number. Let's say when s is equal to -20, we have y is equal to 6 times -20 minus 8 over 2 times -20 plus 4. This will give us -60 minus 8 over -40 plus 4. -68.
-120 minus
Negative
8.
120. Negative
What?
120. Oh.
Sorry. This time this -120. 7. So it will be -128 over -36. So let's divide. -128 divided by -36. We are getting -3.55555. Sorry, positive 3.55555. It's above 3. It's above 3. So any value you pick, it will be getting closer to 3, but you will not get exactly 3. And you can't, it will not fall below 3. That's why we said the graph,
Okay.
the graph cannot be here at this side. So this side is out, it's ruled out. Then you go to the right side of your vertical asymptote. And here, we are going to test values above -2 up to infinity. I use 0. Normally, when you substitute 0, it's very simple. That's why I use 0. Somebody can use 2. Somebody can use 4. Somebody can use 6. Somebody can even use 100. All values above what? 2. To test whether the curve will be at this portion or at this portion. I'll get it. And if you want, you can even use more than one test point. I use one test point, but I can use more than one. You can test -1, and you plot it. You test 0, you plot it. You test 1, you plot it. Test 2, you plot it. Then when you are convinced that it is here, then you just join your line through. You just join your line through.
Okay. Okay.
Book doctor,
God bless.
Yes.
please, can you have a situation where the denominator will be a quadratic? When you
Yes.
factorize, you'll be having two vertical
Yes.
asymptotes.
It's our assignment that they gave us. That's how it was. So
Okay. Thank you.
if it's quadratic and you have two vertical asymptotes, for example, if I have 2 over s plus 1, s minus 1, the asymptote will be going to be equating the denominator to 0. So to be s plus 1, s minus 1 is equal to 0. So we are going to have s is equal to 1 or hot negative 1. Good. And this one is bottom heavy, so our horizontal asymptote y is equal to 0. So in this scenario, let's assume negative 1 is here. Then we have positive 1 here. Good. So here you test here. You test here. Test here and here for the original equation. So let's plug in some values and see whether we can test. The original equation is 2. This is a random question, so when we run into error, pardon me, it's a random question I pick. So 2 over, so y is equal to 2 over s minus 1, s plus 1. Okay, so a number such as negative 2, we are going to have 2 over negative 2 minus 1, negative 2 plus 1. So this will be 2 over negative 3 multiplying negative 1. So it will be 2 over 3. Negative 2 over 3, is that not it? No, positive 2 over 3, because when you multiply, you get positive. So it means for this side, this one is ruled out, because our negative 2 over 3 will be above the s-axis. Remember, the s-axis is the horizontal asymptote. Here is the horizontal asymptote, because we said it is bottom heavy, so its y is equal to 0. Good. So the curve will look like this here. This is our y-axis. Then you come and test here. X is equal to 1, so we can pick something like 2. Y is equal to, sorry, when s is equal to 2, we can have 2 over, sorry, this one is what? Negative 1, it's 1. Okay, so we can pick 2. 2 is correct. It's within the range. So we have s plus 2 plus 2 plus 1, and then 2 minus 1. Then we are going to have 2 over 3 times 1, which is 2 over 3. And 2 over 3 is still on top of the s-axis. 2 over 3 is still on top of the s-axis. So it will be here.
Hello.
Yes.
Yeah. So when it happens like this, it means that you can't take any values between the two asymptotes for testing.
Yeah. Yes. The absolute, when you put it inside, the function will not be undefined. But when you put 1 here, the denominator will be 0. Hello.
Yeah. But my question is, assuming the first asymptote on our left, let's assume that over here it is negative 2.
Yeah.
So it means that you cannot test between negative 2 and then positive 2. You cannot use the numbers
No.
between
You
negative
can't use
2
the
and
you can't use the actual numbers.
okay.
You can't use the actual numbers. But there are other numbers you can use, plenty of them.
Okay. Okay. Okay.
So here we have 1 and what? -1. So when we come to this side, there are a lot of numbers at this region that we can use. And then here too, there are a lot of numbers in this region that we can use. But when we have two asymptotes, the graph will have a portion of the graph either here or here. And we need to test that. So we also test this
Yeah,
region.
that is what I'm trying to ask. Whether you can have a graph between the two
You can have.
vertical. Okay.
You can have. So you test the behavior of this area too. For example, s is equal to 0. If s is equal to 0, we get 2. But for when you have two asymptotes, one thing about the middle one is that the middle one normally behaves so funny. Sometimes you can have top and down. Sometimes you can have it even running through, something like this. So to test the middle one, you have to use more test points between this range to see the behavior of this shape. So let's take note of that one too. Whether it
Thank you.
cut across or to just be at one part of the curve. But after the left and right is to be either at the top or bottom. Here to either at the top or bottom. But in the middle, sometimes behave funny. It can be here and here at the same time, or it can just be at one place, or sometimes even it cuts across the asymptote. Let me even use a graph calculator and then sketch this one quickly and see. It was 2 divided by bracket s minus 1 bracket, then x plus 1. Good. So let me clip it and come. So with the graph calculator, that's what it gives me. For the function, I just let me clear it so that it comes so clear. I don't know whether you can see it. This is what it gives me. So our right and left side, we had it. We had the right and the left side. And the middle is what I said we should test. Test very well and see the behavior. So this is how it should have behaved. So when you pick more test point and you see that all the values are below the horizontal asymptote, then it will look like this. Do not go and touch it. I hope I'm clear.
Thank you, Doctor.
Good. What is the time now? I don't know whether we can do another one. It's 6:30. I wanted to close at 6. Okay. Okay, let me just jump to an example that will contain.
Book Doctor.
Yes.
Please let's solve two questions from the past question.
Do you have it?
If you can write.
Okay. So I'm ready now.
All right. It says find the vertical asymptote into brackets, if any, exists for the curve of the function f of x is equal to x squared minus 16 over x minus 4.
Which one are you looking for?
So we are finding vertical asymptote.
Vertical. Okay. The rules for the vertical is 1. The first rule is that check for common factor. Common factor among the numerator and the denominator. Remove if there is that becomes a whole. If there is that becomes a whole, the remaining is the VA. Okay, so let's look at this one. It is x squared minus 16 over s minus 4, which is x minus 4 s plus 4 over s minus 4. So there's a common factor. So when you take this one out, there is no longer a denominator. So there is no VA. There's no VA, but a whole. And the whole is the one that can cancel out. So x minus 4 is equal to 0, s is equal to 4. So this is a whole, not a VA. So in this one, there is no VA. Is that okay?
Yes.
Okay. Do you have another question so that we
Okay.
can?
Yes, there's another question.
Okay, let's look at that one too.
So, yes.
Please, can we use this one for the horizontal asymptote?
Okay, horizontal. Let's look at horizontal. Horizontal, x squared minus 16 over s minus 4. So this one, what is, which case is that? The case 1, bottom row.
Third case.
Yeah, case 3.
Third case.
Case 3 is top heavy. Top heavy,
Yes.
no HA. This case 3. This case 3. Top heavy. So there's no horizontal asymptote. But there will be what? An oblique asymptote, because the difference is 1. So if you're asked to find the oblique asymptote, then we are going to use our long division. X squared minus 16 s minus 4. This goes here, x times s times we have x squared. This time we have minus 16. Then perform the first subtraction. This goes off. Then
Minus 4, not minus 16.
minus 4x pentembly. Okay. So let me write this. Very well. Minus 4x. So this and this goes off when you subtract. The 16 has no counterpart, so it will come here again. And then the 4x, we don't have a counterpart here, so it's like 0 minus 4. So we become plus 4x. I hope we will understand that.
Yes.
Okay. Then we perform another one again. We go to the last step. Let's go here, plus 4 times. So this will give us 4x. Then this will give us minus 6. So when we subtract, everything goes off. So the quotient is x plus 4. Normally we are not interested in the remainder. So the slant or oblique asymptote is x plus 4. The slant or oblique asymptote is s plus 4.
Okay.
We can solve the last question.
And let's solve the last question.
That one.
I
Yes.
bar off. So
Find the oblique asymptote. The oblique asymptote.
Okay.
For the curve g of x is equal to x squared plus 5 over x plus 1.
So straight away we know that it is case 3. No HA. And that's why we say that we should find the oblique asymptote. And we do that by long division. Let me even write this one well, so that when we are subtracting, we will not suffer. So I can write this one as s squared plus 0x plus 5 because there's no term in x, so I can bring it there. So s plus 1. This one goes here, s squared x times. When I multiply this, I'll get x squared. When I multiply this, I'll get x. Then we perform the subtraction. Here will be 5. This will be x minus 0x minus this will give us negative x. 0x minus x will give us negative x. This one goes off. Then we go again. S goes here negative 1 times. When I multiply, I get negative x. When I multiply, I'll get negative 1. Then I perform the subtraction. This will give us x, but this will go off. And in oblique asymptote, we are only so the oblique asymptote or the slant asymptote is y is equal to x minus 1. This one. Okay.
So, sir, what happened to the remainder, sir?
Pardon?
What happened to the remainder, sir?
We don't need a remainder. The asymptote will be the equation you get or the expression you get when you perform the division. The remainder is not necessary. It's
Okay,
only,
thank
we are
you.
only after the quotient. If there's no other question, then I'm bowing out. Those who join later, I will put I'll put the videos within.
Sir,
Yes.
Thank you very
so please,
much.
the slight asymptote, do we draw it on the graph, or we just have to get the
Yes, if you want to
quotient?
draw
That's
it.
all.
Yeah, if you are sketching, if you want this one, you are sketching, you have to draw the slant asymptote. So
So how?
this is y is equal to x plus what 1. You pick any 2 points, it's a straight line. Mhm. When x is equal to 1, y will be equal to what? 2. Not it.
Yes.
That is so 1, 2.
1, 2. Okay.
When s is equal to 0, y will be equal to 1. So that's 0, 1.
Yeah.
So after drawing your, let's go back to that question. The question. So here the vertical asymptote will be negative 1. That not it. For the bottom,
Yes.
vertical asymptote negative 1. So you draw your negative 1. Let me use a different color so that you can. So we draw a negative 1, which is somewhere here for the vertical asymptote. My VA. Then the horizontal asymptote, we have 1, 2, and 0, 1. So let's assume 1, 2 somewhere here, and 0, 1 is also somewhere here. So the same way, when you test this side to see whether the thing will be here or to be here. See, we have gotten our 4 compartments. We have gotten our 4 compartments. So you also plug in to test whether it will be here or to be here. After that, you pick values beyond this side and also test whether it will be here or it will be squeezed into this corner here. That's all. You just test. You just
Okay.
plug
Thank
in.
you.
Yeah, so Doc, after getting our lines, you said we have 4 compartments. So in testing, you said we should test in respect to the original equation that was given to you.
Yeah, the original equation. Okay, let me just test one so that to clear our doubt. So the original equation was x squared plus 5 over s plus 1. Is that not it? So y is equal to s squared plus 5 over s plus 1. So we are picking values. This is negative 1. So if you want to test, we pick values below negative 1. So somebody should give a suggestion. When x is equal to, let's say, negative 2. Is that not it?
Yeah.
We always pick a number that will be more convenient for you to calculate. Don't go and pick any huge number like 10, 20, and above. So we are going to get y is equal to negative 2 plus 5. Negative 2 square plus 5, and then negative 2 plus 1. So this will give us 4 plus 5. That will give us 9. Positive 9. Is that not it? And this will give us negative 1. So we are getting negative 9. So the coordinate will be negative 2, negative 9. So negative 2, negative 9. Let me assume to be somewhere here. An assumption. I didn't draw the scale, so to be somewhere. So the moment is somewhere there, then it means uh, this compartment is out. This stand. So this is out. This will stand. Uh, so my curve will look like this over here. Then want to test.
So,
What? Yeah.
please, I realize you wrote the.
Oh, sorry. I mistakenly unmute you. Unmute yourself, please.
Yes, sir.
Uh-huh.
Please, I said you wrote the slant asymptote as y equals x minus 1. But when you were texting or when you were choosing the values, you use the x plus 1 rather.
Oh, okay. So it's one error. Okay, very good. Uh-huh. So
Thank
we
you.
use the wrong equation. Very good. So y is equal to x minus 1. So when s is equal to 1, s is equal to 1, y with 0. Is that not it? When s is equal to 1, y is equal to 0. And that'll give us 1, 0. And when s is equal to 2, so we use 0. When s is equal to 0, when s is equal to 0, y is equal to negative 1. So 0, negative 1. Okay. Okay. But is it to be the same principle? To be the same principle, where's the curve? So we have 1, 0, and 0, negative 1. 1, 0, mm, and 0, negative 1. So to be somewhere here. So my line should have come here. Is that not? Yeah. So it is still going to be the 4 compartment. Mm. This line should have come down here, but we will still get the same 4 compartment to test. I hope you are getting me. So this,
Yes, sir.
so let me just clean this one. These are some of the petty mistakes we are bound to make. So let's all be careful.
Hello.
Selection.
Hello.
Yes.
Please, I want you to go over the long division for me.
E.
Is it when finding the oblique asymptote?
Like this one.
Yes.
Okay, let's redo it quickly.
Is it like when solving polynomial?
Yeah, it's like how when dividing polynomial division. X squared plus the original is x squared plus 5 over s plus 1. Normally, when you don't have, you can just write the x squared plus 5. It doesn't matter. But because we perform some divisions, we want to get the like terms within. So in polynomials, the powers reduce to the constant. So if here is x squared, the next one should have been x, which is missing. So you can just write 0x there, then plus 5. So that when you perform the addition, you have the like terms that you perform the subtraction so easily. Uh-huh. So we have x minus 1. Is it plus 1 or minus 1? It was plus 1, eh? It's plus 1. Okay. S equal to x squared x times. Then we multiply the s by everything here. S times this is x squared. S times this is x. So we have got the like names as I was talking about. Then we perform the subtraction. 5 minus nothing is 5. 0x minus x. Remember, I said it's 0x. 0x minus x will give me what? Negative x. Then perform the next division. This goes to this one, negative 1 times. Then multiply it by everything. Negative 1 times s is negative x. Negative 1 times 1 is negative 1. Sorry. Then we perform the subtraction. When you subtract 5 minus minus 1 to give you 6. Remember, we are subtracting 5 minus negative 1. We tend to become plus is 6. Similarly, when you have what we have here, it will be negative x minus negative x, which will be negative s plus x, and to go off. So that will end our division. So it means the quotient is s minus 1, and that will be our oblique or slant asymptote. Oblique or slant asymptote. Y is equal to s minus 1. My yam map on 7. Nam pesa kame ponte na mi yadie. But I hope after this session, there nobody will have a challenge with asymptote. Mm-hmm.
Yeah.
Yes, we'll play back. We'll pull back the video.
You post the video for us to do enjoy.
Okay, I will post it. I'll post the link right now. Those who want to watch online. Then later on the day, I'll prepare the offline version. So maybe by 12 midnight, I'll prepare the online version.
Please also send a slide on this one for us.
Okay.
Police, I want to put this suggestion. Why can't we solve the assignment that was given to us in group?
So it's a very good idea.
Is it EMA 203? He said we should submit it on the 15th of this month.
Statistics.
Is it the one on the 15th? Is it not
statistics?
Yes, the introductory statistics.
On the 15th also.